Then we did adding surds, where we had to have like surds to be able to add them, and we had to simplify some of them before we could add them. Multiplying surds. Okay, so again, like algebra, you don't have to have like surds to multiply. You can multiply anything. Okay, so to multiply surds, and I think it's probably easier if I just jump straight into the examples because they make more sense than those formulas at the top there. To multiply surds, all you have to do is multiply the numbers underneath. Okay, so you go root 3 times root 5, and I will get square root of 15. 3 times 5 is 15. Okay, multiplied surds. Square root of 5 times square root of 5. Using that same rule, that would be the square root of 25. However, whenever you have a square root of 5 times square root of 5, then the square root is going to cancel out. Or the square root of 25 becomes 5, the nice whole number 5. So that was this rule at the top here. When I square a square root, then it just becomes the number underneath.
Can you square 15? Straight.
No, I can't square root 15. Guys, we ready? Yeah, obviously not. Part C. When there are numbers out the front, we multiply those as well. So 2 times 3 is 6. Multiply the numbers out the front and multiply the numbers underneath. 5 times 2 is 10. Okay, they're probably even easier than adding. Okay, you just multiply. For D, multiply the numbers out the front. So minus 3 times 7 is negative 21. And multiply the numbers underneath. 3 times 8 is 24. However, look at that number, 24. Charlie, what do I have to do to that number?
Square it.
No.
Simplify.
Pay attention. Simplify it. You should always be on the lookout if you can simplify your surds further. And 24 is one that's going to have a perfect square number that I could take out of that. 4 times 6. So let's split the surd to be square root of 4 times square root of 6. Now the square root of 4 is 2, so it's minus 21 times 2 square root of 6. And now I just multiply the numbers out the front. Minus 21 times 2 is minus 42 root 6. Okay, that's multiplying. Okay, most of the time pretty simple, but just look out for the extra simplifying part as well. Now into dividing. Now, girls, really, stop please. Dividing, most of the time, you can see one down here, most of the time that you divide is going to look like fractions, okay? 1/3 over the top of the other. Now, the rule that is up there at the top of your page, actually let's have a look back at it, is that you can turn a surd on the top over another surd. You can turn it into one big surd with the two numbers underneath, okay? Let's do that, and you will see that it actually comes out really nicely. So the two little surds, we turn into one big one, 20 on the top, and the 2 on the bottom. All that then does is it gives me permission to divide those numbers together. 20 divided by 2 is 10. So it just becomes square root of 10. And I'm sure some of you will probably prefer just to go straight from here to here, and you can. If as long as those numbers divide nicely, you can just simply go 20 divided by 2 is square root of 10. They won't always be nice though, which is why you also have to be able to split them up as well if we need to.
You don't lose marks if you just write it straight.
That kind of question would just be worth 1 mark, so no, you wouldn't lose marks for that. Okay, so question 2. Okay, there's only one surd there, so you kind of look. You don't want to divide root 20 by the 2 because that 2 doesn't have a square root sign on it. Okay, we can only do this if they're both square root signs. So what I have to do for this question is try to simplify the root 20 first. Okay, simplifying. So 20. 5 and 4. So 4 is the perfect square. So go square root 4 times square root 5 over, and we're just leaving that 2 there. It's just got to wait until I'm ready to deal with it. We're simplifying the surd on the top. So square root of 4 is 2. So it becomes 2 square root 5 over 2. Now, these normal numbers, I call them normal because the surd's a little bit of a new thing. The normal numbers out the front, they cancel just like any normal fraction would. If I have a 2 on the top and a 2 on the bottom, cancel them out. And I just get square root of 5 left as my answer. Girls, last chance, or you are not sitting next to each other. Shush. Part C. So this one's a bit of a mixture. We have our big numbers at the front and we have our surds as well. So looking at the surds, let's start with the surds. The 12, when you look at that 12, you're thinking that can be simplified because it can be divided by 4. So let's break that one up. Let's simplify it. So 16 root 6 over, I'm leaving everything else. All I'm going to do is simplify that root 12. It would be square root of 4 times square root of 3. All right, let's keep simplifying it. Leave the stuff on the top. We have to keep writing it all down. The square root of 4 is 2. And I'm going to run out of room if I don't do this. 2 times 18 is negative 36 root 3. Oh, it's an 8 because I copied it down wrong. Thank you. It should have been an 8. It was an 8 from the one above. Let's fix that one. So that was a negative 8. So it should have been negative 16. That's better. All right. Now, once my surds are simplified, let's see what else we can fix in there. We can cancel out the 16s, right? Okay, 16 on the top, 16 on the bottom. They're going to cancel out. How about the 2 surds? Haley?
How did it become a 16 at the bottom?
Because the square root of 4 was 2. 2 times minus 8. Okay?
Does it matter if there's a negative?
Yeah, the minus sign is going to stay there. Okay. Yes, it does matter. We need to keep that minus sign. On the next line, the 2 surds can be changed to be square root of 6 on the top and square root of 3 on the bottom. Or in other words, we could just divide them. Remember, a surd on the top, surd on the bottom. We do have that minus sign still there. 6 divided by 3 is 2, so that just makes negative root 2. Now, I do suggest that you simplify your surds before you start trying to simplify these numbers at the front like I did, because what you'll find is if you simplify these first, you might just have to do it again. When another 2 comes out of here, we'd have to simplify even further. So simplify your surds first, then simplify your other numbers, and just to save you repeating yourself, okay? Does that make sense? Cool. All right, D. A divide sign is the same means a fraction, same process. So we are dividing, we have minus square root of 30 divided by square root of 10, which we could change to be one big square root sign of 30 over 10. Okay, it's combining the 2 little square roots into the 1. And all I have to do is divide. 30 by 10 is 3. So it's negative root 3. Just dividing the numbers underneath that square root sign. All right, question 3. We then want to move into expanding brackets that involve surds. Now, again, algebra, right? It's all your same algebra rules for expanding stuff out. This one is going to be a distributive law, we call that, where I multiply what's out the front by each thing inside the bracket. So root 3 times 3. Okay, we put the whole number first at the front, so that'd be 3 root 3. Okay, then a plus sign. Then I want to multiply root 3 times root 5, which means 1 square root sign, multiply the numbers underneath, which is 15. Look for simplifying. That's it, can't simplify it. Can't divide by 3, like we can't divide it and make it any smaller, so that's it. Yeah. Okay, and the next one, distributive law as well. Later on, we'll even do the ones with FOIL. You looking forward to those? What? Not yet, not yet. Do you remember doing quadratics where you did FOIL, the FOIL expansions? Anyway, not yet. We'll just stick to these ones for now. Okay, so expanding this one out again. 2 root 5 times root 5. Now, 2 is the only whole number there. Root 5 times root 5. You have a choice. What's the shortest way what's the easiest way to write? What is the easiest thing to write for that?
25.
You can write square root of 25, but that's why I said easiest. You can do that, but it does just go straight to 5. Okay, square root of 5 times square root of 5, the square roots cancel out, and you just get times 5, right? Because when you have, that was the rule that I showed at the front of the page, when you have a square root of something times by itself, squared undoes the square root, and it just becomes the 5. Okay? All right, so that's what we're doing. Second one, I have a minus sign, and I'm timesing 2 root 5 times 3 root 6. So times the numbers at the front. 2 times 3 is 6. And then times the numbers underneath. 5 times 6 is 30. Looking to simplify, 5 times 2 is 10. Can I simplify the square root 30? No, that's not a perfect square. It has to be able to be divided by a perfect square number. So 4 doesn't work, 9 doesn't work, it doesn't work. Okay, so that's it. That's it. Easy.